Hey guys, Budget RC here with another video. This is going to be another upgrade. This time we're going to be working on my Stampede 4x4. Right now my Stampede 4x4 has the stock 2-pole Valenian motor with the stock ESC. To be perfectly honest with you, I'm real happy with the speed. I think it's got a great amount of torque. The only couple of complaints that I have is that, one, because it's the old 2-pole style, it has what I think is too much cogging at low speeds. And secondly, I find that this setup gets very hot. I run in a lot of grass, and between the tall grass and these trencher tires, this system just seems to get really hot. I've geared it down as far as I can gear it down. I'm running either a 9 or 10 tooth pinion, I forget which. And I've still had motor temps a bunch of times over 180 degrees. That said, the motor's still hanging on. It's doing great. I have had some issues recently with the speed control suddenly starting to flake out. So that prompted an upgrade. What I've decided to do in order to try to address the heat is to try to go to a bigger motor. I looked at some of the longer 36 series cans. I looked at 3660, 3675s, etc. What I ended up deciding on was going with an 8th scale 40 series motor. I think the larger motor will allow it to run cooler because it's not going to be stressing the motor as much because it's such a powerful motor. I also went with a little bit lower kV, and I figured I can more than offset that with a higher tooth pinion. Again, with the torquier motor, I should be able to get away with a higher tooth pinion without having heat issues. It's a little bit of an experiment. I may try to keep it geared down and go to 3S. I'm not real sure yet, but at least initially I'm going to try it on 2S and see where it gets me. What I decided to do, again, because this is budget oriented, there are a lot of great combo kits out there. A lot of them will run you $150, even $200. I took a little bit different approach. I've had great luck with the Hobbywing speed controls that I've used before. They're not the cheapest out there, but I consider them to be the cheapest of the reliable brands. I went with the WP SC8. This has been around for a few years. It's hardly a new design, but it's good, it's reliable, and it's not a lot of money. I picked this up on eBay for, I think, a little over $50. I did buy the matching program box for it, although I do plan on interfacing through the USB port to try to set up the software via my PC. But the programming card, for the sake of convenience, will also come in handy. And lastly is the motor. Like I said, I went with an 8th scale motor, 2650 kV. It's one of those no-name motors from eBay. So far I've had pretty good luck with these no-name motors. Pretty simple. Not a whole lot to show on the motor, but hopefully it'll do what I need it to do. One note is that these 8th scale motors use a 5mm shaft instead of the smaller 3mm shaft, and so I did pick up a pack of new pinions from Novak. This is the 3-pack. It's got a 15, 16, and 17, so it should give me a little bit of maneuverability. We'll probably start with a 16 and see where it goes. So the next step here is going to be to install all of this hardware. And I'm not going to videotape the entire procedure, but I will videotape a couple of steps just to show some of the highlights. I haven't done this before, so it'll be a learning experience for me on this vehicle. As you can see right now, everything's completely stock, with the exception of an added little bit here for an FPV rig I was running temporarily. Like I said, I was real happy with the way this motor performed, other than the cogging and the heat. You can see that I do have a heat sink on here, but I was still getting temperatures that were pretty high. The motor did survive. So we're going to try out this new motor. As you can see, it's quite a lot larger. There's going to be some work to do here. We're going to have to take out the old motor and speed control, Dremel some of the material away from the chassis to get the motor to fit, and then see how much room we have left over for the speed control and figure out how we're going to mount that. There's not any room to move the servo, obviously, so I may have to get a little bit creative with the speed control. So as I take it apart, I'll probably take a few snapshots, turn the video camera back on a couple of times, show folks how I dremeled things out, But this isn't going to be a step-by-step. There's already a bunch of those on YouTube if folks are looking for them. This is really more to evaluate the hardware. So anyway, that's it for now. I'll be back as we make some steps. Hey guys, it's me again. Through the magic of video editing, I'm back now with no motor, no speed control in my Stampede. What I wanted to point out was that, as I had mentioned earlier, there are some pieces on the chassis that are going to need to be dremeled out in order to create clearance for the new motor and speed control. I also wanted to show one of the great things about the Hobbywing stuff is that they come with a lot of extra parts that can really prove to be very helpful. And this is a perfect example. On the Stampedes, the speed control, and I think it's not just the Stampedes, but anything that uses the speed control. The factory speed control, instead of being Velcroed down, actually screws down. You can see one of them goes through one of the servo mounts, and there's a mount on the other side for another screw, which is great. It holds it in really tight. However, it can pose problems when you put new speed controls in. However, Hobbywing includes this little plate, which gives you some mounting options. You can see that the holes line up right there. You can also turn it this way, and this hole is offset, so depending on your application, go this way, go this way, and this one is even flush mounted, which is probably the way it's designed to go. But it gives you some options for mounting without having to hack up your vehicle. In my case, it's not really going to help, and I'll show you why. Again, this is where the motor sat originally. I didn't swap the plate over yet, but you can see this is where the new motor goes. So it's quite a lot larger. So what I'm probably going to have to do is to come up with some sort of a mounting scheme that allows me to mount the speed control right here. And if you look, it looks like there is going to be ample room. However, I can't mount it flat to the chassis here, because in order to have this room, it does have to go over the servo. So I may wind up using some sort of modified version of that plate that they gave me, or come up with my own plate that will utilize this position here and still use this and this and this as a stand. Something along the lines of this. So I'm not sure yet. The first step is going to be to fit the motor, and then we'll see what we have for room once that project is completed. So that's it for now. Hopefully next time I turn this on, we'll have more. All right, so we're back. As you can see, I've done some cutting here. We've made a lot of clearancing. We had to cut away this back section here to make some clearance. We cut away about half of that stud, maybe a little more, and we cut away the sections through here that used to cradle the original motor. And now this should fit into here, and you can see it fits nice and snugly. We will still need to cut away the clear shield that goes over the drive shaft, but we'll get to that a little bit later. And best of all, because we still have some of this post available, I should be able to fit this in here once I trim it down. And once that when I trim that down to fit it in there, we should have plenty of room for the speed control to sit just like this. So I think this is going to work out really well. So after we get that piece cut and installed, we'll come back and we'll show you where we're at. Okay, and we're back. We've got the motor mounted, and now you can see that we have the plate here. I had to take some of the material away from it to get it to fit. Once I did that, it fit really well, and I think this is going to be a great spot for the speed control. So now we're going to go ahead and mount that up. Okay guys, here's a quick video on 2S just to show the cogging we get with 2S. We're going to take off real slow. So you can see that there's some cogging. It's not terrible, but there is some cogging. Okay, so now I've got an old phone strapped to this with a GPS on. If this thing will ever focus, no, it doesn't want to focus, but 4 miles an hour is the peak so far. Now we're going to take a run or two. Let's see what we have. Maximum speed, 21.25 miles an hour. Even if this won't focus. Okay, so we're here on 3S. We're going to give it a try, see what the cogging is like. Well, it's slightly less severe than the 2S, but still very noticeable. Now we'll do a speed run and see what we get. Alright, so now we're going to try to do a speed run on 3S if I can keep the front end down. Top speed is behind, wow, that's a heck of an improvement. 45.86 miles an hour. So we more than doubled our speed going from 2S to 3S. I've got to be honest, I'm pretty shocked. I never expected to see that kind of a difference. Well, let's get a car to go by and we'll try one more time. Uh-oh, uh-oh. Alright, we had a nasty tumble out of the truck because I wasn't paying enough attention. But, top speed, 47.5. So, overall, I'm really surprised at what we were able to accomplish for a top speed. And we're back in the studio. I hope you guys enjoyed watching this thing tumble. As you saw, I had a hard time controlling it on 3S. At first, I thought it was just because my steering trim was off. But upon further investigation, I discovered that I broke another front drive shaft. I say another, can you even see this? I say another because every single time I've run this vehicle on 3S, I've broken a front drive shaft. Never broken a rear drive shaft because I bought this vehicle used and it already had the MIP Extreme Duty drive shafts in the back. And they've been fantastic. However, every time I've run 3S, I have broken a front drive shaft, and this was no exception. We broke a drive shaft, so I went ahead and ordered a set of those MIP Extreme Duty drive shafts for the front so that won't happen anymore. But I guess it explains why I had some issues controlling the vehicle. That said, as you saw, there was a really, really profound difference in speeds between 2S and 3S, which really surprised me. On 2S, this truck was just really slow, and I was pretty disappointed in it. Obviously, this motor is a 2650 kV. That's a much lower kV than the 3500 kV Valenian that was in this. However, I did step up from an 11-tooth pinion on the Valenian motor to, I believe, a 16-tooth pinion on this. And in doing so, I had expected top speeds that were very similar, but we just didn't get that. Top speed was in the very low 20 mile an hour range on 2S. However, This motor came alive when we moved up to 3S, and we saw 47 miles per hour. I'm just absolutely astonished that there was such a difference from 2S to 3S. It's very clear that this 8th scale motor really needs 3S or more to come alive. So that said, 47 miles an hour is really faster than I want or need from this vehicle. My target speed is typically 30 miles an hour, maybe a little bit higher if I want to be a little bit crazy. That's about what my son's circuit runs. That's about what my father's ruckus runs. And then that's about where I want this to be able to run. The areas that we play, we really don't have a lot of room to go much faster than that anyway. So what I'm going to do, I've got some more pinions on the way, and I'm going to try gearing this down. I'm going to try 11, maybe 12 tooth pinion on this, and see if I can get this down into about the 30 to 35 mile per hour range on 3S. That way I'll have a top speed right around where I want it to be, using 3S, so that hopefully we'll get low temperatures and good run times as well. Additionally, I'm hoping that by gearing this down, it helps with my cogging situation. As you saw in the video, this vehicle seems to cog more than I expected. By all accounts, it really shouldn't cog that much. It cogs just as bad as the 2-pole Valenian motor, which had a reputation for cogging. In my father's ruckus, I have a 2-pole tack-on motor, and it has no cogging at all. And that's using a Hobbywing Easy Run 60 amp speed control. This is using the Hobbywing SC8, which is part of the Easy Run family, and I believe it runs the same firmware as the other one. However, whether it's the motor or the speed control, I'm inclined to think it's the speed control. It has a tendency to cog. I've read that other folks with the same speed control had similar issues and wound up moving on to different speed controls. We'll see. I really want something that's reliable and waterproof for this vehicle, and I don't really want to keep spending more money. So I'm gonna see if I can stick with this one. The cogging never really bothered me on the Valenian. It's not like I crawl this thing, so we'll see what it does. I think when I gear it down, it should help it a little bit, and hopefully it'll be okay. So overall, I guess I'm a little bit disappointed, but you know, what are you gonna do? We didn't spend a lot of money on this setup. You know, we're only looking at about $75 for 8th scale hardware. So I think this is one of those cases where you get what you pay for. That said, even though I am disappointed, I think it's still going to be a good setup, just not a great setup. But we'll keep running it, and we'll see what happens. Maybe if I get to a point where I want to make some changes, I'll try a different speed control with it. But anyway, that's my review. I hope somebody was able to learn something. If you have any comments or questions, please feel free to leave them below. If you've had experiences with these pieces of equipment, please share your experiences. I would love to hear whether you've had cogging with either this motor and or this speed control. It'll help me maybe decide what I wanted to do next. So anyway, until then, hope you guys enjoyed this, and we'll see you next time.